Hello everyone, my name is Nan. Today I'll be presenting our work, Human-in-the-Loop Video Semantic Segmentation Auto-Annotation. In this work, we focus on reducing data annotation cost for video semantic segmentation task. Training a deep learning-based semantic segmentation model needs a lot of data, but the cost of segmentation annotation is high since it needs per pixel annotation. The cost is even larger when it comes to video-level annotation. So far, there's no public video dataset with per-frame labels. They only provide sparse labels. But video-level annotations is desired since we can use them to do video-level training or evaluation. In this task, we generate video semantic segmentation annotation given sparsely annotated samples. Different from the common annotate once then propagate methods, we introduce the human-in-the-loop annotation framework, which uses annotation budget more efficiently. When populating annotations to all the frames, traditional label propagation method only use spatial temporal information. Therefore, they do not take advantage of semantic information captured in a semantic segmentation model, leading more manual annotations to fill where the spatial temporal constraint do not cover. We replace the label propagation method with a semantic segmentation network and fine-tune the network on the input sequence using existing human labels. Other than normal cross-entropy loss, we added a new loss function, temporal consistency loss, considering spatial temporal consistency in model fine-tuning. Test time fine-tuning requires some label on the input sequence. Most existing work only use naive strategies. These strategies do not consider the video content or domain knowledge. We propose active sample selection method. It evaluates the prediction uncertainty of the network and will only select samples with low confidence score. Also, it clusters the high uncertainty samples and selects the cluster centroids for human annotation. In this way, our active sample selection method selects uncertain and representative samples to improve the utilization of manual annotation budget and boost the label propagation accuracy. We chain active sample selection and test time fine-tuning components. The whole process repeats until high-quality semantic segmentation annotations are achieved. One of the critical considerations is the granularity of annotation unit, including frame-based, rectangle-based, and superpixel-based works. We studied this in the video semantic segmentation setting. Moreover, to ensemble real-world manual annotation process, we adopt the click-based annotation measurement to simulate annotation cost rather than the traditional pixel-based measurement. We compared our method with random selection baselines. Our active sample selection outperforms the baselines in all sample granularities. Rectangle 16 gives the best annotation MIOU with fewer clicks among all the granularities because it provides better sample diversity than larger samples. This diversity favors model fine-tuning when annotations are limited. As annotation clicks increase, the gap between all the settings becomes smaller. This table shows the most efficient sample granularity for different MIOU benchmarks in CNET. For example, to achieve 80% MIOU, we should annotate 16 by 16 rectangle samples as it's the most efficient among all the granularity options. We observe that the optimal granularity in video annotation tasks is not determined, but depends on desired level of annotation quality. Another interesting finding is the object boundary quality in predictions. Models trained on frame samples outperform the others. The reason is frame-level annotation provides the richest semantic and boundary information. On the contrary, the superpixel-based selection is usually composed of pixels of the same object, which lacks the information of the object boundaries. This is another factor to consider when you decide what granularity to annotate for your task. Here are some visualizations for our auto-annotation given different amount of manual labels in a vast dataset. Here are more examples from CNET dataset. Thanks for watching.